Lots of prospects. Yeah, that's the problem. That is the problem. Mm.
Boxing match afterwards.
Because you played.
I did kind of.
Well, let's do a show.
Oh god, okay, you win.
It's like nice.
No, I know. I know. I know. Do you think you were right or was?
Being recorded, by the way.
Thank you. Thank you, sir. Fucking anyway. No. You're free. Not out. Bro, I really don't want to criticize. It's true. I'm not doing this. I will be doing LO.
In our, I really need the bathroom. And if I take like 10 minutes to get there to get back.
Okay, I'm not asking
No one's saying
questions.
anything. Okay.
I'm not asking questions.
Oh wait, I can go to the one down here, right? Yeah, probably. Or down here, because I can't make it.
Okay.
Everybody having is a video. Yeah, it's fine. Where did I bring that here? Thanks. I need to bring maybe that's also my face. Yeah. Stakeholders and shareholders. Stakeholders. They're very long. Shareholders, they mention explicitly who the shareholders are, Alan Gray. Stakeholders, they said it's the customer, it's the employee, something else. There were four of them, but those are the stakeholders. So the stakeholders can be affected by the business and can affect the business. But so shareholders, shareholders, they just have shares in the business.
Yeah,
But-
shareholders don't really have a say in the business. So the board, so the duty of the board is to make sure that the shareholders are like at best interest type of thing.
Yeah.
Right, fun, Martin, doing this stuff. Yeah.
I'm really my choice. Okay. Good, I found out how to that shape my state. When you go to that website, just tap on the imagine for fun. Thank you. How much did you study here? I mean, I've got notes. Are they good? That's what I think. My notes are literally my pre-Googled answers. Oh, yeah, that's what I did. And then I asked my.
I'm not going to create population watching that few doesn't.
And then I asked my mother.
Bro, take the. You've got these, get them out. Or let's be taking the these. Just not happy you guys with it.
Yeah, so why should I use the office?
Right, thank you.
My notes. It's like they're reading out to sound. Oh. What? Because see, what is that? They can do
all the businesses and they can able to sustain the family.
How much?
Yes. Clothes, drinking.
But I might not feel like running.
Alright, guys. Let's smash this. Okay. All right, everyone got these notes?
Maybe.
Okay. Right, grab your notes. You don't have to get it more. Yeah. Okay. Well done. Yeah.
It's well done. Sometimes I just forget that I need to speak English. It just slips out.
It's actually kind of hard, actually. Right.
Sorry about this, but so the fourth syllabus is pretty much finished. Okay, I think you're right, Caitlin. Right, okay. So, I'll practice one or two application questions. You've been sent that thing on when your revision is going on holiday, whatever. Okay. Up to you, it'll be online, it'll be here. Okay, so reminder quickly, head back into it. Okay, first model was what? Malthusian, right? Okay. What happened in Malthusian? Okay, population grows exponentially. It's just exponential growth, right? Okay, but at some point, okay, you reach a critical point and the population collapses, right? Okay, you're not given that formula. Okay, that formula was p to the n plus 1 is equal to p to the n 1 plus r. What does that parameter r stand for? Okay, your intrinsic growth rate, right? Okay. So you could also write it as an explicit model. What is the formula for that? It's just like a finance model. Okay, but instead of a equals p1 plus I to the n, you could say p to the n is equal to p0 1 plus r to the n, but we generally work with recursive model. Okay, r, this intrinsic growth rate, is equal to what? Birth rate minus death rate. Okay, birth rate is equal to what? Okay, number of surviving of the original. How do we normally calculate birth rate? What's the formula we use? Okay, percentage female times number of surviving offspring. Okay, in a population time period, right? D was the death rate. How do I normally calculate death rate? Check here, because I read it right. 1 over life expectancy. Okay, 1 over. Are we good with that? Okay. Right, there we go. There's Malthusian growth rate. Okay, remember, you can get a situation where they kill a certain number every single year, right? Okay. And so you minus X. Okay. If they say to you, how do I reach, how many do I have to kill per year to reach equilibrium? Well, you can just let p to the n plus 1 be equal to p to the n and solve from there. Does that make sense? Quite noisy, yeah? Okay. Right. Okay. Are you happy with that? Okay. Right. Now, then our next model said what? Was the logistic model. And that said that growth is a function of population density. Okay, that your logistic growth rate. Okay. So sorry, before we do that, that population growth slowed down as the population gets denser. So it starts off intrinsically, okay, but then it has a point of inflection and heads towards a maximum value. What's that maximum value called? The carrying capacity, right? And K over 2 is where you get this point of inflection, right? So growth slows down, yeah? It's an asymptote, but it's a theoretical asymptote. In reality, that doesn't happen. Okay, in reality, okay, it fluctuates around that point. Okay. Right, so that is your population. What the axis here? The axis here is n for time, okay, and this is your population, right? But then, okay, we get another model that relates to this model, okay, and that says that this parameter called logistic growth rate, okay, constantly slows down. Okay, the formula for logistic growth rate, which is not the same as Malthusian growth rate, is delta P over P. Okay, and when is a maximum logistic growth rate? When does that occur? Well, when is that? It's the same as the intrinsic growth rate. Okay, intrinsic growth rate is optimal growth rate, right? Okay, and what happens is that decreases constantly. Okay, and the minimum logistic growth rates. Okay, so this is a graph of delta P over P against population. What's that saying to you? that growth rate slows down as population increases, which you can see from that graph. But this is a measurement of the actual growth rate, where that's the measurement of the population. Okay, so it slows down. Okay, it reaches its minimum growth rate. In other words, a growth rate of 0 where? When the population hits carrying capacity. Okay. Your formula is on the formula sheet. Have you guys got formula sheets? Who doesn't have one? I'll take it once. Okay. Am I recording, by the way?
It's, I don't know. It's red line.
Okay.
The red line means I'm sharing the screen.
The red line is recording.
Sharing.
Promise you. Promise you. Right, who needs this? That's all. Yeah. Yeah. Okay. Right.
You want to do a quick test?
You are stubborn, do you know that? Right. Look, it's recording there. Caitlin, you don't have to always be right. Right. Okay. Now.
Okay, right. So now, that's our logistic growth rate over there, right? It's constantly okay. Our formula is what? It's on your formula sheet. Okay. The what's its name formula is not on the formula sheet, the Malthusian, but this one is. And let's see if I can remember it. So P to the n plus 1. What does that mean? The population in the next cycle is equal to P to the n plus how the population grows is proportional. The bigger R, the more the population grows. Okay. The bigger the original population is, the more it will grow, right? Okay. But then it's going to have this parameter here, 1 minus Pn over K. Am I right? Okay. From the formula, what does this formula tell us? Okay. As R gets bigger, okay, if your natural intrinsic growth rate is high, okay, your increase, this would be your increase per annum. Okay, you with me? That's how much that's your initial population. This is how much the population grows by in a year. That's the number of growth in a year. Fish. Okay, so as R increases, what's going to happen to the population? It's going to increase, which makes intuitive sense. If a species can breed naturally quicker, okay, rabbits are going to breed quicker than elephants, right? Okay, if it's just as well, I guess. Okay, if this thing gets bigger, what happens though? Yeah, even though there's a minus sign, if K gets bigger, Pn over K gets, okay, and so you're minusing a smaller amount. Okay, so overall the whole thing gets bigger, which again makes sense. Why? Because the larger the carrying capacity, the more room there is for growth. Kavish? Okay. This, by the way, what I'm doing right now is a good way of studying. Okay. You literally teach yourself, you literally write down what you know. Okay. And then you'll realize, actually, I don't really remember what was going on here. Okay. You get those tables. Okay. Remember, you get a table where you ask to find the logistic growth rate. If I had this, the logistic growth rate is a smooth growth rate. So if I had this was n, and that was Pn, and we had those tables, and this, let's say, is P2, and that's your population at 4. And I want to know the logistic growth rate, in other words, delta P over P at P3. Okay, your smooth growth rate. What do? Okay, it's the average gradient between these 2 points. Okay, so I find the average gradient between those 2 points. How do I find the average gradient? It's just the gradient of the straight line, right? So it would be equal to P, so logistic growth rate, delta P over P would be equal to, here you've got P, I'm confusing myself. Sorry, yeah, that's N. So this is your population. That's a GO2, that's a GO4, sorry. So that'll be 4 and the population at 4. So it'll be P, and this will be 2 and the population at 2. So it'll be P4 minus P2, okay, over 4 minus 2, which is always going to give us 2 divided by what? Okay, the function of population. Okay, the bigger the population gets, what's this formula telling you? Delta P over P. Saying the bigger the population gets, growth slows down. growth rate slows down. Okay, because population is an inverse function of density. As the population gets more and more dense, diseases spread, there's less food. Okay, so that's why it's an inverse function of what your population is at 0.3. Okay, that's what probably was, I think, the most confusing concept. Okay, about this section over there. That if you take logistic growth rate, what is it? Okay, it's the average growth rate, so P4 minus P2, change of Y over change of X, as a function of what? Okay, as a rate with not respect to time, with a rate with respect to their population in the middle. Fish? All right, so that's to know so far. Okay, then we went on to this model over here, the predator-prey model, which is our third type of model, which really explains the relationship. Okay, and so in a strange way, both models can almost apply at the same time. Okay, because they're kind of looking at slightly different things. Okay, we're on page 26. And the key thing I think with this model is really what I've done here in this first page. Okay, is to understand. Okay, well, let's just have a reminder of what's actually going on here, what the predator-prey relationship says. Okay, and that's this model over here. So on the spiral model, where you have prey on the one axis, prey is always going to go on this axis, and what's chowing the prey is going to go over there. Okay, otherwise known as a predator, right? Okay. In the end, what we're often going to do is we're going to divide it into quadrants because the behavior is similar, and the quadrants are formed with the origin, if you like, okay, at your point of equilibrium. Okay, because the same behavior happens in the same quadrant. What's happening in this quadrant over here? Generally, predators increasing and prey is increasing, right? Everywhere in this quadrant. In this quadrant, what's going to happen? Generally, prey is now decreasing. Why is prey decreasing? Because predator numbers have increased, right? So prey starts to decrease, but it hasn't had a knock-on effect yet on the predators, right? Okay, so then predators are still growing. In this quadrant, what's going to happen? Okay, well now, okay, prey is going to start, it's still decreasing. Okay, but now predators start to decrease because of there's less prey. Now the predators have died off. So what starts to happen? Okay, well, that's good news for the rabbits, right? So the rabbits start to increase in number, okay, but the foxes are still recovering, okay, from this loss of prey. And then we repeat that cycle over and over again. Initially, the changes are dramatic, okay, but then it settles into some type of equilibrium. This point over here is the equilibrium of the relationship between predators and prey. Okay, and that equilibrium can be offset by something can go wrong, and the whole relationship can change. Okay, so that really is what the model is saying. Within that, I'm just thinking to myself, it's not necessarily a contradiction completely of the logistic model. Why not? If I think of population numbers, what happens to population numbers in both models? They settle at a point, right? Okay, both models' population settles at a point. Okay, that's the one thing that they do have in common. Okay, they both reach some kind of capacity. They settle at a particular value. Okay, all right, I'm not going to get too into the details here. So for me, okay, understanding the formula here is really important. Okay, these are on, surely you've seen it on the maths, that big notice board, like the biggest formula there. Yeah, it looks very impressive. Okay, what is this telling you over here? Okay, let's remind ourselves, we did discuss it the other day. Okay, that the number of rabbits in the next population cycle, okay, just have a look here for a second. First of all, okay, is equal to, that's the number of rabbits the year before, right? I want you to change this over here to birth rate. Okay, so A is your birth rate, okay, of the what? Birth rate of the rabbits. Okay, this thing here in this whole yellow block is what? What does that yellow block represent? The number, the increase per population in that population cycle. How many more rabbits there actually were? Okay, so this, because it's got a plus sign in front of it, this is how many more rabbits there were than the year before if they hadn't been hunted. Okay, what is that formula, by the way? That's your logistic formula, right? Except for what? except for what? There's one difference. So it's not quite. Instead of instead of R in the logistic, that A would be an R, right? And that R is a growth rate, not a birth rate. Okay, and what does R include? Death rate and birth rate. So in the logistic model, death rate is included over here, where this A is. Okay, Sugaman. Okay, death rate is included over there. Where do we deal with death in this model? We deal with death separately over here. This is essentially the number of rabbits that have been chopped by that particular predator, right? Okay, now this part over here. So look at this part in yellow. Okay, we're gonna have a break in 10 minutes. Okay, because I'm talking a lot. Okay, so in this particular model over here, A is your birth rate. Okay, obviously they're going to be more. The bigger your birth rate, the more rabbits are going to be born. That's what a stupid statement. Okay, right. But what's R to the N? It's proportional to R to the N. What does that mean? Well, the more rabbits there were, the more rabbits will be in the next population. Which one population has 1 million, another has 10. Which population is going to have more births the next year? Okay, so it's proportional to R to the N. Again, the business of K we talked about. K is the carrying capacity of what? It's the carrying capacity of the rabbits. Okay, for that particular region.
Oh, it's the K.
Okay,
Sorry.
all right. How are we going to calculate A? Well, A is a birth rate, so we're going to use the same logic we used before. Okay, percentage female times litter size, the number of litter, basically percentage female times number of surviving births, right? Okay, and a key idea, okay, which took me a while to figure out. Okay, when working out, unlike when working with R in the Malthusian model, death rate does not have to be taken into account as B times R to the N times F to the N. Okay, this over here is where death is dealt with in that model. Whereas in both other models, death is dealt with as part of R, your growth rate, because R is equal to birth rate minus death rate. Okay, right. So now these little rabbits that are dying. Okay, what's it proportional to? Okay, well, you get this parameter B. Basically, B means, okay, are they pretty good at hunting? Okay, so in this particular model, okay, the number of deaths, this is how many rabbits are going to die, right? What's it proportional to? How good they are at hunting. Okay, your per capita rate of fatal attacks. Okay, the more rabbits there are, okay, the more are going to die. And the more foxes there are, the more rabbits are going to die. That's pretty obvious, I think. Okay. Then, predator-prey model. Okay, then you get given this formula, which is for all predators, okay, which we've symbolized with foxes. Okay, fox to the N plus 1. Okay, now the growth of foxes is symbolized by, what is this number here? It's the increase in foxes per annum, okay, per population cycle. That's how much they've increased by. Okay, so what is it proportional to? Okay, well, obviously, the more rabbits in the previous population, okay, the bigger the fox population is going to grow. Okay, this over here, this parameter, okay, F. F is basically how good they are. Okay, I think it actually stands for something called fecundity. Fecundity. Okay, somebody Google that for me. And LLU. Okay, yeah. But I might be completely wrong. Okay. Don't know why I suddenly thought that. Okay, yeah. Yeah. F is for foxes. So this is your predator. The previous one was for what? Okay. This described the number of rabbits in the next population cycle. R is for rabbits, but it depends on the foxes, right? You with me? So this is the increase in your rabbit population, which is proportional to the rabbit's birth rate. Okay, the rabbits are what gets eaten. So the rabbit formula is for anything that's being eaten in the relationship. In other words, the rabbit formula is, that's for the, I'm speaking, yes, for the prey, right? Whereas this formula is for the, who's chowing, yeah. Okay. This is the predator, right? That should be number of predators. Well spotted. Okay. Predators. No, it's a scientific expression. If you when you go to basketball, they prefer if you talk about Foxy Woxy. No, man, they love it. They know you're intellectual. Yeah, right. Okay, right. Right. Okay. Right. Okay. So let's just quickly finish the page and we're gonna break, yeah?
Multiply mated females show increase in.
Erin, just amazing myself. Right. Okay, so yes, the ability to have babies, right? Okay, so the rate in which they can turn food into babies, right? That's what your job is. Your job in life is to turn food into babies, right? Okay,
I was just.
right. Okay, well, you're more useful than us, right? Okay, right.
Yeah.
Can turn popular by catching the prey and then having F is a constant for each specific predator-prey relationship. So then we have a value F for lions and impalas. So we have a different value F for lions and dassies. Okay? Kavish? Okay. The lion will have to eat more dassies to get more babies than it would have to eat giraffes. Kavish? One giraffe? Good news. One dassie? Not so much. Okay. Right. Yeah.
Boxy is.
What's happened to our dassie? No, I haven't seen Dave for ages.
Nice thought, sir. I nearly stepped on the nose.
Recently.
I really did.
Boxy is not a real name, a real word.
That's what I imagined.
The fox Foxy. What?
Pregnant fox.
Pregnant.
What did you call it?
F.
Fertile.
Fecundity. Right. Okay. All right. So if so, obviously, guys, hey, the better they are at having babies, the more babies there'll be. Right? Okay. Of turning food into babies. B is what? What B is the same as in the previous one. B is what? Essentially, how good they are at hunting. Okay. Are they good killers? Right. Okay. Then the death rate of predators. How many predators get lost? Okay. The number of predators that get lost is proportional to their life expectancy, right?
So wait, which ones? Predators that are lost?
C is no, careful. C is equal to 1. This is the number of predators that get lost in
The whole.
whatever comes after the
Okay.
minus. Okay. This is the loss of predators in a year. Change two things on this page quickly. Okay, right? And so C is 1 over lifespan. Okay. And C times Fn is the number of foxes that die in one time period. Okay. Then R to the N is a prey at N. Okay. B times R to the N is the number of prey killed in a given time period. Okay. All right. You with me on that?
Yeah.
Okay, right. It is now 11:20. 3 minutes. Guard finder. No chance. Right. Okay. But you can go 3 minutes.
I like to ice cream. Sorry, remember that one time Joey and I went to go pull the ice cream and came back in time?
3 minutes.
3 minutes. Oh yeah. That's the challenge. Go.
You would need to start running now.
Not the bottom field. What time is this double in?
Uh,
10 to 12. Yeah. That's a long time. It's 3 till 10.
No, don't stop recording.
No, I'm not gonna stop the recording, sir.
Okay, stop sharing. Control H.
You're first stubborn.
I am. So you go here.
Go into it.
Where?
Into the meeting there. Press join. Go
Okay.
sharing. Stop sharing.
Where the
Oh, yeah.
Yeah, so I think it's not right. I just want to say.
Okay.
All right, Caitlin, you win.
Some of that not simple thing. Hey. That's what we're doing now. Okay, I'm gonna do it.
I will wake up tonight and I will not like I will not want to wake up. I woke up late today. So I'm about to work here. Yeah, the whole morning. All I want to do is sleep. Come 8 o'clock at night, I just get like this surge of energy and I am up until 11 and I don't know why. So that's my weird. Huh?
We went
Yeah, I got out of my bed at 6:45.
I got up there and put it to them with my mom forgot to wait. That's why I was late to school.
And then I said,
I left my house at 7 today. I was up at 5 today. Why? Really? Yeah, I had a workout that I needed to do. He's 6 in young keeps.
insane.
I am.
Exercising does not make you young. That is scientific.
Yeah, but it makes you fit.
Yes.
Wait, and being fit keeps you healthy.
It increases life expectancy. Right, okay. So,
It does look like oh yeah. Can I tell you something? It looks like you're trying to jump over something, and then they force us up you. Oh my god, look at that.
maybe
That Rhapsody. That's
right, let's go, guys, please.
They're actually not as bad.
I should be signing a signature.
I'm famous. Thank you. My story. Actually, boring.
Or you should actually have your wife.
Oh, look at that.
Why don't you? Why don't you?
Right, okay, let's go. Okay.
No, but it's really not fair.
They haven't sent out all the invites yet, guys. Decisions are still being made. Relax. Okay,
It's so sad.
right, let's go, let's go.
Cassie doesn't get it right.
It hasn't all been before. Okay, right. Sports and the non-academic ones have not been decided. Okay, right. So, guys, okay, now you're going to deal with this concept of equilibrium. In other words, in the spiral that you have of prey against predator, okay, how do we go find this point over here? Okay, this point over here in red, okay, is your that's your equilibrium point, right? Where the population stabilizes. Okay. And at equilibrium, what's happening? The population is not growing, right? It's stable. So the other key idea with equilibrium is that P in n plus 1 is equal to En. That is a key idea with equilibrium. Okay. And a very common question is to go derive a formula for equilibrium. Okay. When you ask to derive a formula for equilibrium, okay, you've got to prove, first of all, and it's a bit weird, okay, equilibrium in the prey population. In other words, in the rabbit formula, Rn, shouldn't have been real numbers in, I don't know why I did that. Okay, in Rn, okay, using the predator formula. So to get the equilibrium formula for rabbits, we use the Fox formula. Okay, you'll see now. Okay, so to prove equilibrium for rabbits, okay, the equilibrium formula for rabbits, we use the Fox formula. Okay, then, okay, we use the rabbit form to prove equilibrium for foxes. You use the Rn formula and your solution. But there's quite a lot of theory in this model, and your solution from 1. So to prove equilibrium for foxes, you use the rabbit formula and your solution from 1. In other words, the solution you got to Fox equilibrium question. Read it again to you. Okay, so you prove equilibrium. First thing with equilibrium, what do you have to remember? Equilibrium happens. What is equilibrium point? When the population settle, right? That happens when P to the n plus 1 is equal to Pn. Prove these formulas we're going to prove now. First of all, you're going to prove equilibrium, okay, in the fox population, okay, using the rabbit formula. What? No, prove other way around. Prove population in the rabbit formula using the fox formula. Then I'm going to prove equilibrium in the predator, in other words, in the foxes using the other way around, in the rabbit formula, right? And I'm going to use my answer that I got in part 1 to do that. You got that? I see you guys again.
Yes.
Wait.
Technically on Monday. No, probably not actually. All right, everyone got that?
Then we're done with it. Ah,
Well, we must plan to finish with fun. It's just long, but I'll do some revision with you. Okay. The biggest thing is there are a couple of tricks. Number one is don't work out your answers, and you guys won't do that a lot of the time. But sometimes you get these long formulas. Okay, I literally don't do this. This allocated 1 mark. And like if you have 15 mark question, 1 mark will be on. You write the formula down and it kills you guys. Putting that into a calculator takes a lot of time. Okay, good. I never give on final answers if I'm trying to do it in the time
Then
allocated.
you lose a mark.
Because I'd rather lose 1 mark there than
You'd rather,
marks by
you'd
100
rather,
in the paper.
you'd rather lose one
And
mark.
my hint is do your mod. The paper
Then
is
you
always
get
said,
99.
it's usually
91.
said that the finance questions come before the modeling. I would do the modeling questions first, then I do the finance questions. Okay, finance questions, it's not so much the difficulty of them, it's actually the calculator work in particular, which is tedious.
So
Okay,
is the modeling.
and I would, sorry, one other thing. If you've got one variable that you're solving for, use the solve function. Okay, right. Okay, see, we've got the queen of solve function, yeah? Okay, right. Okay, sorry, yeah. Yes, but the difference is I think it's easier. Okay, I think the other difference is I find I have to, the biggest problem with stats is you can go on the wrong path fairly easily without knowing you've gone on the wrong path. Right, that is the biggest problem with stats. You think, okay, it's the one exam where you can walk out and think I smashed that,
Yep,
and you didn't.
yep.
Okay, because the right path, wrong path often feels like the right path. Okay, and there's a lot of, I find when I do stats, I personally think the stats exam should be 15 minutes longer or 15 marks less, because there's just that rereading of questions where I have to always find a double check myself in that. Okay, right. Anyway, let's finish this. Okay, so what time is Belga? What time does the lesson end? Say 11:50. Yes. All right. When do you leave Cape Town?
I leave school at 1, but our flight is only at 4 because we have to go to the awards center. So.
Right. Okay. So anyway, right, equilibrium. Okay, so it says here, equilibrium point, and often they ask this question exactly like this in an exam for like 15 marks. Okay, or 10 marks. Equilibrium point is reached when both predator and prey populations are stable, i.e. blah, blah, blah. You can memorize the formula below, but rather just use the above principles. It can be shown that predator-prey populations will reach equilibrium when, okay, remind me what this formula means. The rabbit population, equilibrium will be equal to what? Be careful. C stood for what? The lifespan of what? The lifespan of your predators, right? Okay, that's your lifespan of your predators. This is all in terms of predators. This is why we use all these parameters really have to do with the predator, right? Okay, the rabbit population, that's the lifespan. C is the lifespan or life expectancy, eh? Okay, so the death rate is 1/C. Okay, F is what? Fecundity, the ability to turn food into babies. Okay, and V is the hunting skills. So what is this bottom formula saying? That the better they are at hunting, okay, it's inversely proportional. The equilibrium point of the rabbits is inversely proportional to how good the prey are at killing. Does that make sense? Okay, and how good they are at turning Okay, the higher this is, more babies the predator has. Okay, the more babies the predator has, then the less rabbits there'll be. Okay. All right. Okay. So, first thing, to prove this formula, first of all. So I want to prove this. Okay. Required to prove. So what am I looking for? Equilibrium points in the rabbit population. But it depends on all those parameters have to do with the prey, right? We're going to use the prey formula. So just copy that formula down. So it is what? Jolie, tell me Fn plus 1 is equal to Fn plus Fn times B. Oh, the little f, sorry. That's little f times B times Rn times minus C Rn Fn.
No, no.
C Fn. Yeah. Okay, sorry. Minus C times Fn. Right? Okay. Now, at equilibrium, what happens? Fn plus 1 is equal to Fn, right? So, at equilibrium, Fn plus 1 is equal to Fn. Okay? Now, we're proving this formula. It's a proof of this formula here, that the rabbit population reaches equilibrium at C over FB. The actual, the formula, no. The proof you have to know. Yes, very much. You have to know this proof. It's easy. Okay. So you're going to get asked, you can be asked to find the equilibrium. You're often asked to find the equilibrium. Okay. I don't ever learn this formula. I always actually prove it. No, even when I'm using it. Okay. So I go replace Fn plus 1 with Fn. So I get Fn is equal to Fn plus F times B times R to the N times Fn minus C Fn. I've just replaced. That's all I've done. Because that's equal, because we took what at equilibrium, and that's what we work with. When do the populations stabilize, right? Fish? Okay, what are we trying to isolate? Rn, right? Okay, so I'm going to actually move this just to get rid of the negative. I'm going to move that term to the other side. Okay, what's going to happen to these Fn's? What's Fn minus Fn? Those two over here are going to disappear, right? Okay, and I'm going to move the minus Cfn to the other side. So I end up with Cfn, okay, is equal to what? Well, this Fn's also gone, that one's gone. So it's going to be equal to F times B times R to the N times F to the N. What can I divide both sides by? Divide both sides by Fn. And I get C is equal to F times B times what? Rn. We want to isolate Rn. So C over F times B is equal to Rn. There's one thing that confuses me, but I'm not going to tell you. Why is yeah, I think so. No. The thing that confuses me here, I understand C. C is the life expectancy of the predator, right? Okay, so it makes sense that the bigger the life expectancy of the predator, is C the life expectancy of the predator? No, what does C stand for?
Yeah, it is.
This is the number of predators that die, right?
Yes.
Okay. So what's C equal to? 1 over life expectancy. Okay, that makes sense. Sorry. Okay. So actually, this formula could be thought of. If C is 1 over life expectancy, don't write this down. Well, you can actually. Okay, but you're never going to. So actually, this formula would be equal to 1 over life expectancy of the predator times F times B. Does that make sense? And that makes more sense. I was thinking that C itself was the life expectancy. C is 1 over the life expectancy.
What is? Sorry.
C is the death rate.
Death rate.
C is the death rate. Okay, so in other words, C is equal to the death rate of the predator, right? Of predator, which is equal to 1 over life expectancy of the predator, which then makes sense in the formula. Okay, because the higher the death rate, if C is bigger, then Rn will be bigger, the equilibrium point of the rabbits, right? Why? Because more the life expected, because C is a death rate of your predators, right? So the bigger your death rate of your predators, the better it is for the rabbits. Okay, the bigger F and B are, though, the worse it is for the rabbits. Because F is how the lions breed and B is how they hunt, if you want to think of it like that. All right, okay, so we ended up with this. So now we've got Rn is equal to C over FB. What we got till 1150. That you can make it, right? Everyone stand up for 30 seconds. Stand. Stand. I know we're at the end of term. Okay, right. Grab the person opposite you, or next to you by their left ear with your right, but their right ear with your right hand. Right? Jody doesn't want to.
It's called the.
Right.
Yeah, but they right here by my right hand.
Sit down, right, let's go. Okay.
Yeah, I was abused, but okay.
All right. Next. Okay. Is it not more space yet? Okay, you're gonna have to go onto the other page then. Okay, I don't know, you're gonna have to find some space. Okay, just divide. All right, you've got space. Great. Okay. So now I'm gonna do the other one. Okay. So I know two things now. Okay, what did part 2 say in the summary that I gave you?
But you have to prove the equilibrium for the predator using the Crane formula and solution to.
Okay. Right. So now we've got to prove this thing over here. I'm proving that equilibrium for foxes happens when? At A over B, 1 minus C F times B. No,
No, it says on the
Okay,
tip
in the
of
time.
Okay, let me, can I just confirm that color?
1150.
So then we could into now.
Yeah.
Whatever, so it should be now.
And then the next lesson is back to like normal, back to an hour and 10 minutes.
Is it?
Yeah.
Yeah.
No, I like it's complicated. Right. Okay. So to prove equilibrium, first of all, I'm going to use the rabbit formula, right? Tell me the rabbit formula, somebody. Rn plus 1 is equal to? Skate.
Okay. 1 minus Rn over K. Minus BRN.
Thank you. Right, so now I'm going to prove this thing over here. What is that thing over there? It's the equilibrium number for expected equilibrium for foxes. Okay. But what's the key idea? At equilibrium, what happens? Good. R to the n plus 1 is equal to what?
Oh, it's equal to R in. Well,
Okay. Right. At equilibrium, that happens, right? So go to your formula and replace R to the n plus 1 with Rn. Sorry. And well, the thing is, you can leave out a few, I guess. Okay. Now, minus B Rn Fn, right? So what's going to happen? Those two R to the n are going to disappear. That one and that one, they're going to cancel out. Do you agree when I move across? Okay. And I'm going to end up with, I'm going to move this term on the yellow here to the left. So I'm going to end up with B R to the n Fn, okay, is equal to A R to the n 1 minus Rn over the carrying capacity. What can I divide everything by? Rn. So I end up with BFN is equal to A 1 minus Rn over K. What am I looking for? Equilibrium of boxes, right? Okay. So I want to get Fn on its own. Okay, so I get Fn is equal to A 1 minus Rn over K divided by B. You could. You want that right? But Rn at this was also like this, but at equilibrium, we worked out that what is Rn? At equilibrium, Rn is equal to C, the death rate of the predator, over F times B, right? So you're going to go to this formula and replace Rn with FB. I've never learned these formulas in my life. I always just derive them. Okay. So then I get Fn is equal to A 1 minus CFB all over K. So that what did we have to prove? To prove it was equal to, okay, yeah, 1 minus CFB all over K, all divided by B.
Oh,
All right. And if I tip in times,
so it's so ugly. Okay, you can just.
hang on, minus C over FB, so you can just someone put it, Judge.
Yeah.
Okay, so if you tip in times, that would be times K is, what do you end up with?
C over FBK.
Why? Okay, title what? What?
Rn times 1 over K.
Oh, yeah, you're right.
Is it times what?
Hang on, if you take out Rn from where?
The top.
Rn was in the bracket.
So if you.
You just say 1.
Oh, there you go. Sorry, I was just gonna talk.
So that's Rn over K, right?
Go to spend.
Wait.
Yes.
Oh, she is not.
Okay. So it's Rn times 1 over K. You get the same thing as that.
Rn, yes, okay, nicer, yeah.
And then you sub in this and you get
C over, yes, okay, nicer. Okay, so we're gonna, instead of saying that, we're gonna say, thank you, Kajal. Okay, nicer. Minus, okay, Rn times 1 over K. Okay, right. So minus N times 1 over K. But Rn is equal to C over FB. So you get one minus C over FB times 1 over K, all divided by B, which is equal to A 1 minus C over FBK. I think it's enough for one day.
Yes, I agree.
So it's the same as the formula because the formula has A over B and then the bracket.
Yes, it's the same thing, which is the same thing as A over B. Learn those, highlight those, very common question. Okay. All right.
Wow.
Me? What? Oh, yeah, I don't think I've ever seen like. I always do this.
Do we have another AP lesson?
Hello, yes, we do on Monday.
On Monday, okay, so Monday, you guys are, you're coming here again.
We have the last few lessons on Monday.
What do you mean, oh damn, you've still got design to do,
Yes, we might now.
I'll report it. No problem, I'll have a lesson, but try what's reporting first.
On the last of the lessons on Monday. If so, then we may, if you need them to go away. I didn't feel well.
And because the final is late yesterday, there are no flights from Cape Town to Joburg, so I have to come back.
You'll be back to Joburg.
Yes, he says I'll in, but the only flight that was available was at like 12 on the Monday, so I'm gonna be back in Assembly, but I'll be at school.